Hello wonderful person, this is Anton, and in today's video we're going to be talking about a very interesting topic of, how do you actually find really cool exoplanets to read about, how to actually find more information about those exoplanets, and obviously we're going to explore at least one of them and then use Space Engine to go and visit it as well. Welcome to What the Math and enjoy the video. So for this particular video, I'm going to actually use several things. I'm going to show you one of my most favorite free applications known as Eyes on Exoplanets. This is actually made by NASA itself. This is what you see in front of you. It's sort of a demo version here. This is a Spitzer telescope that is responsible for finding many of the exoplanets. Now, if you actually download this, which is absolutely free and it's totally worth downloading, right under the latest discoveries here. This is how I usually go about finding cool planets to talk about or cool new discoveries. Right here, it always shows you some of the more recent discoveries, some that have already been published. Like, for example, this is Proxima Centauri, the exoplanet closest to us that's very Earth-like and is essentially our closest neighbor that is somewhere right here. And it also is orbiting in the so-called habitable zone that you can see right here. So a very exciting find. You can read more about it. Now, unfortunately, Eyes on Exoplanets doesn't provide you with enough information though, but it does give you a basic idea on what we've discovered. And some of the latest discoveries here are basically these three new planets. This is from November of 2016. The publication, it has not been published yet, so published. I just used publication twice. Anyway, publication is still pending. Basically that, this is a discovery, but it's still being double checked. And we're going to go through some of these new discoveries, but this is the one I actually want to focus on because this is a pretty cool planet. So let's take a look at ogle 2015. Also known as ogle 2015 BLG0051L. This is really far away from us. This is actually more far away from us than the central black hole. Essentially, this is 26,000 light years away. Earth is somewhere over there, really far. But we were able to discover this unusual planet using a really interesting technique that I'm going to explain to you in a second. But basically, this is why I wanted to talk about this planet. So first of all, it's a normal sort of a star. It's a main sequence star. This particular star is not really visible to us because it's kind of far away. Not visible to naked eye. You do need a telescope to try to see it. It's only about 10 masses of a sun in terms of its actual mass, but the interesting thing is, of course, this. Its planet is inside the habitable zone, meaning that this is an area in space where you potentially could have liquid water and potentially could have some sort of life. So we're going to actually talk a little bit more about this planet. The only problem with this planet is, of course, its mass and its size. So we're going to zoom into it. And so this planet right here is, it's a gas giant. It's basically a little bit less massive than Jupiter, but it is definitely located in the area where you would expect to have liquid water. Now, why would we actually consider a gas giant to be interesting? Well, because it might have moons, just like our own Jupiter and our own Saturn have different moons. This too might have moons that actually might have liquid water on them and might be habitable. But this is the artist's rendition, or I guess the Eyes on Exoplanets procedurally generated rendition of what this gas giant might look like. So let's actually see what else we can find about this particular discovery. So one of the websites that I often use to kind of go through planetary discoveries and planetary information is a website called exoplanet.eu. It basically contains all of the recent planetary discoveries with the publications that you can access directly from here. And it basically gives you information on, like, for example, how was this planet found? And here we're talking about microlensing. And microlensing refers to this really interesting technique where the actual starlight from another star gets sort of bent by the planet that's right here. So basically, we're looking at another star behind ogle 2015, and the source star gets its light bent a little bit by the planet as it passes, as it orbits around the ogle 2015. So this is how we discovered this particular planet. It's a very unique technique, and it's also very sort of challenging to try to calculate some of these parameters, but it is a really original technique, and we've discovered quite a lot of exoplanets using this. So basically, this is based on the idea that if you actually put some kind of a massive object in front of the light that's coming from behind you, the light will actually bend and create this kind of a ring-like effect. This is known as the Einstein's ring because he was the first to describe such, or he predicts such an effect using his theory of relativity. And the actual angle between the light, the original light and the bent light is actually known as Einstein angle. So anyway, so this is how we discovered this planet. And there's also a lot of other information about it here as well. Like, for example, obviously the mass of its star, the apparent magnitude, or basically how bright it is in the sky. The mass of the planet here, it's about 72% of Jupiter, and its distance from the parent star. And here it's just a little bit closer to its parent star than Earth is to our own sun. And so basically that's kind of how I usually find really interesting planets to talk about, or just in general, different planets that might actually not have been published yet. And I do like to kind of read through some discoveries about how this particular planet was discovered, and obviously what we think might actually be happening there. But let's actually go to Space Engine and see what this planet might look like if we procedurally generate it using Space Engine. So now that we're in Space Engine, let's actually go and look for that particular exoplanet, and let's find out what it actually possibly looks like if we procedurally generate it based on the parameters that we know about it. So we're going to go into the search box here and type OGLE 2015 BLG 051LB. So this is a planet or exoplanet that was discovered back in 2015, but it hasn't been classified until very recently. And obviously the paper that I just mentioned has not really been published yet. It's still been reviewed and it's pending publication. We're going to basically click on it and find out where it is located in relation to our own planet Earth that you see in the back there. And OGLE 2015, also known as KMT 2015-1b, because it was also discovered using another telescope, is right there. It's 26,000.7 light years away from us. So we're gonna just fly through it, or fly through this area by pressing G, and let's find out how far away it really is. It might actually be right past the central black hole. Yeah, it looks like it is. It is definitely past the central black hole, right in that region of space that is very, very saturated with various stars and various space dust as well. So this is the planet. Let's take a look at it first. So we're gonna spin around here, and it actually looks a little bit different from what the ice on exoplanets has generated as, but Space Engine does such a better job at basically generating these various planets and stars, because it does use these parameters to generate relatively realistic looking objects. So this is what the orbit of this star is like, or at least we think so. It might not be so circular actually, because it might actually be a lot more elliptical, but there's the star right there. This distance is about 0.7 astronomical units. And unfortunately, we don't really know, and probably will maybe never know, or not for a long time, if there is any moons orbiting around this particular exoplanet. But you can only assume that there are moons, because, you know, it's a gas giant. It's gotta have to have something orbiting around it, because every single gas giant and ice giant in our own solar system has something orbiting around it. So maybe there is definitely some kind of a small moon, or at least a few asteroids around it, that might actually have just enough atmospheric pressure needed to maintain liquid water. Now here the temperature is procedurally generated to be 264 degrees Celsius. We don't really know exactly how much it is, but it is definitely going to be in the region of space where you can have very comfortable conditions for both liquid water and for other potentially life essential materials like oxygen and CO2 and so on and so forth. So whether there is life here or not, that's obviously not the question we're trying to answer here, but this planet or this particular object here is really, really interesting, because it is actually in a habitable zone, and it's definitely something that we one day might want to look into in more detail. Now, so this is where this planet is. This is where it's sort of located and how it looks in this particular game. Let's actually maybe come a little bit closer and take a look at its orbit as well. We're going to make it spin a little bit faster and orbit around its parent star. And here we go. So this is the planet OGLE 2015 BLG 051L orbiting around its parent star as the star sort of emits a lot of light you can see in the back there. Now, let's actually also find out how far away this is from the central black hole, because I'm kind of curious myself. I haven't really seen how far away this is from the actual region where the central black hole is located, but you can see that you can even see these really large globular clusters very, very close to where this particular planet is. We don't really see globular clusters from our own planet and from our solar system, because we're really far away from the nearest one. But this is a kind of a view that you may see in this particular region of space, because here there's so many more stars, there's so much more stuff going on, there's a lot more space dust, there's a lot more really interesting phenomena and locations, and the actual night sky would look a lot brighter as well. Now this is actually not the complete brightness. This is possibly what the night sky would look like here. It would be very, very bright even at night, and you would actually see a lot more stars. So anyway, so let's actually discover or find the central black hole known as Sagittarius A star, and it's actually right there in that globular cluster that you see from this planet. It's only about 2,000 light years away. It doesn't sound like it's a lot, but it is quite a lot. So basically light from here would take 2,000 years to travel. But let's actually just go to it as well and end the video there, because we can actually see the globular clusters from this particular planet, and we can definitely possibly even see the black hole from here in a lot more detail than we would from our own planet. And anyway, so that's all I wanted to show you in this video, and I wanted to talk about these various discoveries, these various exoplanets that we always find using various telescopes, and how you can actually discover the new ones even before they're published and before they become known to the rest of the world. So NASA actually keeps track of them in that app that I showed you previously, known as Eyes on Exoplanets, and you can go download it for free and possibly learn more about the exoplanets that we discover in the near future. Anyway, so that's all I wanted to mention in this video. Thank you so much for watching. I'll see you guys in the next video, and we're going to finish this by going inside our supermassive black hole and ending the universe behind us. If you haven't subscribed yet, don't forget to subscribe. Maybe share this video with someone who enjoys watching space videos and who enjoys learning through video games. And also don't forget to possibly consider supporting this channel on Patreon, because it does help me purchase better equipment. I'll see you guys in the next video. Game you later. And as always, bye bye. And here comes the end of the universe. Ready, steady, go.